Hiya folks, this is question 4. So this is differentiating from first principle. So we have to do f of x plus h minus f of x all over h, and then we have to do the limit as h tends to 0. So that's what you have to do with differentiation of first principle. So it's a proof kind of like question. So it's a straightforward enough one, really. It's not too bad. So f of x plus h, that's always what you do first. So we're just going to find that. So that would be x plus h squared. I'm putting in x plus h everywhere I see x, minus 7 times x plus h minus 10. Then I'm going to square out that bracket into x plus h, and then multiply it out. So we get x squared plus 2hx plus h squared. Then I'm going to get minus 7x minus 7h. Then I'm getting minus 10. So it looks like it's getting bigger, but it should start simplifying a little bit in a second. So next thing I'm going to do is f of x plus h minus f of x. That's the next step, to subtract f of x. So we get, I'm writing out the same thing as the line above it here now. But at the end, I'm going to subtract f of x. So I'm just subtracting basically the original function. So it'll be minus, and then it's just x squared minus 7x minus 10. I'm going to write it out again, but I'm going to change the sign of everything in there. So we have x squared plus 2hx plus h squared minus 7x minus 7h minus 10 minus x squared. Minus becomes a plus 7x, and minus 10 becomes plus 10. Then some things always cancel at this step. So our x squared and our minus x squared over here, they cancel. Our minus 7x and plus 7x, they cancel. And minus 10 and plus 10, they cancel. So that makes things a lot simpler now. So we get 2hx plus h squared minus 7h. Our next step is to divide everything by h. So we're going to get f of x plus h minus f of x all over h. And then if I divide everything there by h, I'm going to get 2x plus h, there's still 1h left, and then minus 7. And then our last is going to be to do the limit of h tends to 0 of f of x plus h minus f of x all over h. So if I just basically put in a 0 instead of h, so that just gives me 2x plus 0 minus 7, and that gives me 2x minus 7. And that's my answer. And you can always check these as well. If you just differentiate as normal that that function. So x squared differentiates into, like, if you find f dash x, it should be the same at the end. So x squared turns into 2x, minus 7x just turns into minus 7, and then the minus 10 is gone. And that's the same thing as we got at the bottom there. So that's differentiating from first principles. Part B then, it's a fraction, and it's one thing over another thing, and they both have x in them. So we have to use the quotient rule here. So the quotient rule is in the log tables. So it's v du dx minus u dv dx all over v squared. So our top thing there will be u, our bottom one is v. So u is equal to 6x plus 1, therefore du dx is equal to, if I differentiate 6x plus 1, I just get 6. Our v is equal to, well, it's x to the power of 4 plus 3. So if I differentiate that, dv dx is equal to 4x cubed. And that's all it is, because the 3 will disappear. So I'm going to put it into all of that up there now, everything I have. So I'm putting down v first. V is x4 plus 3. That's going to be multiplied by dv dx. dv dx is 4x cubed. And then minus u, so u is 6x plus 1. And then dv dx we've worked out is, sorry, I made a mistake. Yeah, my v's always look a bit like u's. So I shouldn't have had 4x cubed in there. I should have had du dx. So du dx is 6. And now it's u, which is 6x plus 1, times dv dx, which is 4x cubed. So that looks a bit better. So all over v squared, and v is x4 plus 3. Right, so you can multiply out the top line just to simplify it a little bit. So 6x4 plus 18 minus 24x4 minus 4x cubed. And that's all over x to the power of 4 plus 3 squared. Right. We can put the x4s together up there. So I'm going to end up getting minus 12x4 minus 3x cubed plus 18 all over x to the power of 4 plus 3 squared. And then I'm going to, so that's what g dash x is, but now I need to find it at where x is equal to minus 2, so I'm just going to put a minus 2 in instead of x everywhere. So minus 12 times minus 2 to the power of 4 minus 3 times minus 2 to the power of 3 plus 80 over minus 2 to the power of 4 plus 3. And that's all squared as well. And if you put all that into the calculator, then I'm getting minus 150 over 361. Part C, so the graph H has a local minimum at the point 0, 5. So if you were to imagine that on a graph, so if you imagine the point 0, 5 is there, so it's a local minimum. So local minimum is not a full minimum of the graph, it's only a local minimum. So what we know is that the graph is going to come down like that there and go up again, but we don't know that that's the full, like that function could come down then like that again. And if that's the case, well then not every real value of x would be, because obviously something down here is below it then. We have an add us below it. So they're testing your knowledge of what local means there. Local minimum, so only a local min. You may have to say something a little bit more than that. A full sentence probably, but that's generally what it means. And a little drawing like that is no harm in that question either. So that's it for that question.